Hello everyone, welcome to day 8, week 8 of the 8-week course on built-in tools that make query tuning easier. It's never easy, but it does make them easier. My name is Grant Fritchie. I work for Redgate Software, and this is just an event free for you guys, teaching you how to do query tuning easier. It's never easy, but we can make it easier. And this is the last class in this series. We've done 7 other classes covering all kinds of topics, from execution plans for 2 classes, almost 3 hours worth of material there on execution plans. We've covered extended events in depth, so if you're trying to learn extended events, or if you think you shouldn't learn extended events, go watch the class, and please, I think you ought to learn extended events. It's great. We've also covered query store, and we've covered DMVs, and we've covered the tools inside of SSMS, including the ability to compare execution plans, the ability to capture query metrics in a way that a lot of you don't know about, all kinds of little hints and tricks in there, and let's see, query store. That's everything that we covered in over the 8-week course. So it was a lot of information over quite a long period of time. So there's a whole bunch of videos out there. Go and watch them all. They're available for you, and they will be free, available forever. So you guys can watch them whenever you need to. 100% free, 100% of the time, for as long as you need them. Today, the course is going to cover automation. There's a whole bunch of new tools that have been introduced. Now, so this is the one part of the course. Every other part of the course applies all the way back to SQL Server 2012. Some of it applies back to 2005, but most of the course applies back to SQL Server 2012. Some of the course is 2016 and up. This part of the course is primarily 2017 and up, and 2019, and then a little bit of Azure SQL Database. But mostly we're talking the more modern versions of SQL Server in this last part of the course. Every other part of the course covered back to 2012 at least. Some of them even further back. But this part will be primarily with the newer versions of SQL Server, 2017, 2019, and Azure SQL Database, because there's just some unique functionality there that's not available in the older versions. And it's all around the ability to have automated tuning that's more automatic, covers what you think it ought to, in more or less the way you would expect it to, frankly. So that's what we'll be covering. Well, let's go ahead and get started today. This series of videos is part of the Redgate Community Circle, and that is just material that Redgate has put out there to try to help out the community right now in the times of things that are going on right now. We just felt that we wanted to help out. We wanted to make sure that we were giving back, and that's all this has been about, is a free thing, lots of free stuff. So check it out and get involved. Other than that, we're going to get going. So today we're talking about automation, query tuning automation, which is a little weird, but it's actually fascinating, the stuff that's available. It's very different. Now, for those who don't know, my name is Grant Fritchie. I do work for Redgate Software, but this is my contact information. If you want to get in touch with me after today, please use it. You've got my information now. That's my Twitter handle. That's my email address. That's my blog. You can track me down and ask me questions. That's it. That's the whole purpose of me sharing this, is so that you can, when you are ready, ask the questions that you need, and I will do my best to help out. So that's why this stuff is published and available, just right out there for people to see. And I forgot to turn off that driveway alarm. Silly me. Anyway, so what are we talking about today? We're talking about a bunch of stuff, but the first thing I want to talk about is adaptive query processing in SQL Server 2017. Now, this stuff was introduced with 2017, but before SQL Server 2017, a lot of this had been introduced in the cloud. A lot of this was already available in Azure before it came out in 2017. One of my favorite things about the Azure SQL Database is how you can get new functionality before it's ever in the desktop product. So if there's things that you need, little bits and pieces of help that you want to get, you can get it there a lot of times when you can't get it inside of the actual product itself. So anyway, what we're talking about today, we're going to talk about these 3 things first. We're going to talk about a bunch of other stuff as well, don't worry. But these 3 things first. So adaptive query processing was introduced, and it was the idea that sometimes the execution plans aren't the best. So there has to be a way for SQL Server itself, the thing that generates your execution plans, things that knows the most about your execution plans, there's got to be a way for SQL Server itself to fix the execution plans, because SQL Server, after all, is the one that kind of broke them, because it's based on the internals of the processor and how everything works, whether or not you're going to get the execution plan that you expect to get. So they went away and they came back with some ideas. First up, most of these use some method of interleaved execution, so that the execution is occurring at the same time as, if you can mute everything going on downstairs, that'd be really handy right now. Anyway, it uses various methods of interleaved execution. This is execution that's occurring in stages, so that it will stop execution to change things. And so if you look at the multi-statement table value user-defined functions, or as I call them, abject evil, I really hate multi-statement table value user-defined functions. Not the multi-statement functions, those the inline views or inline functions, those are fine. I mean, sure, you can write bad code. You can write bad code with anything. But functionally, they work. These things are evil. The multi-statement table value user-defined functions are abject evil. But in 2017, Microsoft introduced this new idea of interleaving the execution such that as it executes, it will go back and revalidate the row estimates. Now, prior to SQL Server 2014, all multi-statement table value user-defined functions, regardless of the data, regardless of the functionality, regardless of anything, use the table variable estimates. And the table variable row estimates is one row. Zero statistics, no kind of statistics at any point. Estimate one row and go. If you have 1,000 rows, oh well, too bad. Your execution plan was compiled for one row. Now in 2014, they quote-unquote improved it, and they made multi-statement table value user-defined functions work on an estimate of 100 rows. Okay, I guess that's better than one, but what if I'm only returning one row? And now it's creating an execution plan for 100. It's still a problem. So now, 2017 and up, if you're on 2017 and up, we have what is called interleaved execution. Now, the interleaved execution means that it will pause the execution and check the row counts. And if the row counts are off based on the original estimate of 100, it will then re-estimate and possibly change the execution plan. Because if it gets different row estimates, you can, see different executions. And so, in fact, this has marginally improved multi-statement table valued user-defined functions. But I really want to emphasize marginally improved. I mean, I cannot begin to tell you how marginal the improvement is. We are not talking even a 10% improvement in most cases, 20%, 30%, something exciting like twice as fast, right? That would be cool. But no, it's for most cases, it is 3 to 5 to 8% improvements. It is not stellar. However, an 8% improvement in query performance is an 8% improvement in query performance. So we will take whatever we can get. So, it's fine. It does it. But there are limits. One, you cannot be using cross-apply inside your functions. You cannot be using the functions in a cross-apply statement. And I know that when you're using functions, cross-apply is a very common T-SQL method that you're going to use. So that's a problem. You cannot you cannot have data modifications through the functions. So that also is a problem. Now, the one thing you can see is you will be able to tell in the execution plans, and we're going to look at the execution plans. You're going to be able to look at the execution plans and see when this is occurring. Yay, cool. But other than that, the only way to really track it is to watch it through extended events. There are a set of extended events that will allow you to track this interleaved execution. It's an improvement, right? So we're going to take it. If you get an improvement, you take the improvement. There's just never any question there, right? But it's a very marginal improvement, so don't get excited. Now, this one's a little more exciting. That's the second part of the adaptive query processing introduced in 2017. And that is batch mode memory grants. And this one's pretty cool because what it's doing is if you're doing a batch mode process, and we talked about what batch mode was in the session on execution plans, the second class on execution plans. Batch mode, I'll give you a quick rehash. Normally in execution plans, you are getting row mode processing, meaning each operator in the execution plan says, give me a row, give me a row. Batch mode processing says each operator more or less goes parallel. Parallelism is not a requirement, not anymore. It was in 2014, but it's not now. It's not a requirement, but it more or less goes parallel, and those parallels ask for batches. Give me 100,000 rows, give me 100,000 rows. And if you think that the difference between give me a row and give me a lot of rows is an improvement, you're right. It's a huge improvement. But batch mode processing is still currently tied to column store indexes. So you're not going to see a lot of that kind of behavior outside of column store indexes. There's some row stuff that does it, but by and large, batch mode is still connected to column store. So doggone. But this is great stuff because what this does is it tracks your memory grants and keeps an eye on how the memory is being granted. And if the memory is too high, it's granted too much memory, it will reduce that memory grant. If that memory grant is not low enough, it will increase the memory grant. And it does that by measuring each execution. Now there is a little bit of bounce. So if you've got queries that are going up and down, you can cause the memory grant to also go up and down. That could be a little bit of a performance hit that you wouldn't normally see because if you have an excessive memory grant for one version of the query and then the next version of the query, that memory grant's no longer excessive, okay, well, you only paid a cost for half of your queries. Whereas if it's a little excessive, it's not quite enough, it's a little excessive, it's not quite enough, it's a little excessive, it's not quite enough, that could be very problematic. But for most of us, most of the time, this is an excellent thing. It's going to revise the memory grant on the fly as it executes queries, and you're going to see a lot of stuff. Now, you can't have recompile hints on it, but you can see the differences in the execution plans because the execution plans actually have the memory grant info, so we can take a look at that when we do the demos. And you can track it through extended events. Again, extended events is your tracking mechanism for modern query processing. It just is. I know a lot of people are happy with trace, and that's fine, right? Trace or profiler, that's fine if all you're interested in it is measuring query performance. But as soon as you want to measure query behavior, especially modern query behavior, you need to move to extended events. Go back and watch my other session on extended events. I think it's number 2 or 3. I forget which. But anyway, great stuff. By the way, if anyone has questions, I will be taking questions through the live chat on this topic or anything else. Just type them right in there and we'll keep going. So, the last thing that they added in 2017 in terms of adaptive query processing is batch mode adaptive joins. I love these things. Now, I showed them off in the last section, in the last class, but I'm going to show them off again today because if you didn't watch the last one, I don't want you to miss out. And this is very much part of the magic of the adaptive query processing, so it's pretty cool. First up, how does this thing work? What's an adaptive join? Well, your two principal join types that you're going to see most of the time are hash and loops. And the reason being is the merge, which is the single most efficient join mechanism, only works for data that is ordered and primarily works best for relatively even data sets. If you've got like a few rows and a lot of rows, or just lots and lots of rows everywhere, it's not as efficient. But generally it is the most efficient mechanism. But it requires the data to be ordered. If the data is not ordered, you won't get a merge join no matter what. Oh well, or you can throw in an extra sort operator to make sure you get the ordered data, but then that causes all kinds of performance bottlenecks if there's not indexes that support it and all kinds of other issues. So we don't try to control based on joins, because the fact is that the joins that we have are actually very efficient. Loops joins work really well for what they're designed for. Smaller set of rows at the top, larger set of rows at the bottom, find the few matches that are likely and spit out the results. Loops joins are efficient. Cool. Hash joins are the join that covers all our sins, all of our bad code, all of our bad data structures, all of our code that, it's joining tables, but there's no filtering mechanism, so we're moving millions and millions of rows, and we've got to mush this stuff together. That's the hash join, and the hash join very much is about protecting us from ourselves. We haven't put the right kind of constraints in place. We haven't put the right kind of indexes in place. We're moving very large amounts of data. We've got to have coverage somehow, and that's the hash join. So the hash join is that catch-all join type, and it is extremely efficient for what it does. But what it does is somewhat expensive because it has to create that hash table, and that hash table has to be created in TempDB, and everything else going on in TempDB is going to cause problems. So there's the deal. Now, when you are dealing with a column store index, and again, it is column store indexes because it's batch mode only, so we haven't quite got it yet in row mode, and we haven't quite got it yet in indexes without column store. But if you are having a column store index and you are getting batch mode processing, what this does is pretty cool. It basically gets the statistics for the tables, and all the tables involved in the join, and says, okay, how many rows approximately would it be better to go with a loops join versus better to go with a hash join? And it makes an estimate. And so let's say it picks 100. Usually it's like 1,200, 1,000, something. It's usually something bigger and higher, but let's just say 100 just so we can talk about it. Cool. There's 100 rows that it thinks if it's less than 100 rows, loops is going to be perfect. If it's more than 100 rows, hash is going to be perfect. So the query starts to process. What it does is it creates a little block and it starts collecting the rows. When it gets all the rows, if it's less than 100, it says, cool, I got less than 100 rows. I'm now going to do a loops join. And it will automatically do a loops join. And so it'll take those less than 100 rows, and it will use that to then do the probe to the lower half of the join and pull all the data back. Cool, win. Now, is that as efficient as if it just did a loops join out of the gate? No, because it has to stop and collect all the data and do a row count. Okay, how many rows do I have? And until it gets all that data, it's storing it in a little temporary storage, little temporary holding pen. And that means that it's a little less efficient than a loops join. But if you are at lower than that count, it is more efficient than simply doing a hash join for that same small data set. That smaller data set that would totally not benefit from a hash join is actually going to suffer from a hash join, benefits from a slightly higher cost loops join. Win. Now, same scenario. 100 row guess. Okay, cool. Starts collecting the data, blows through 100 rows. Everything stops. It throws out the temporary stuff and it says, okay, I now must build a hash table. It resets, builds a hash table, and yeah, okay, it's already processed 100 rows and it reprocesses those 100 rows, but we don't care because it's now building a hash table. Is this as efficient as a hash table? Nope, there's that slight little cost at the front. But is it more efficient than if it had done a loops join when it needed a hash join? Oh yeah, night and day better. So it's really incredible. So this thing is fantastic. I love the adaptive joins. Also, the adaptive joins is the one place you can look at to see that every single execution plan is the same. And then there's execution plans that have additional execution metrics and execution plans that don't. And what we used to call that was an estimated execution plan and an actual execution plan, which are total misnomers, bad labeling, frankly. There is an execution plan, there's one execution plan, period, and then there's an execution plan plus runtime metrics. That's what we used to call the estimated, what we used to call the actual. We are changing that language as best we can because it's more clear to say it that way rather than saying estimated and actual, which are grossly inadequate. Anyway, it's only hash or loops. You'll never see a merge join with it, and it tracks it all. You can track it through the query store. You can see what's going on there, and you can see it in the execution plan. And we'll show you how it works inside the execution plan. I'm not going to do the demo right now. I want to talk about the 2019 stuff too. So, 2019 introduced more adaptive joins, more adaptive query processing. And so it introduced a number of things. First off, you can get batch mode in row store. Now the query has to involve more than 100,000 rows. It has to have analytic operators. But cool, we do get batch mode processing now. It's not, you're not always going to see it. You've got to have the analytic operators, meaning group by and all that fun stuff. And you've got to be dealing with large data sets. If you're not dealing with large data sets, it will not go to batch mode. So you've got to have those larger data sets. So that's cool. We also get row mode memory grants. We can revise the memory grants in row mode. Same as we were getting in batch mode before with the column store. It has to be 2 times or greater on the memory. It has to be over 1 megabyte. But you still get it. Now, you can't have a recompile hint because those aren't even stored. When you have a recompile hint, it doesn't even store the plan. It doesn't. It says, like, recompile, I'm going to be recompiling this every time. So it just throws it away. So it wouldn't be able to keep the memory grant to make the adjustments up and down. So it just, that's just how it works. We also get the approximate count distinct, which is really cool. Now, it does require you have more than 1 million rows, but it aggregates columns with really high distinct values, and it will give you an account really, really fast. But you have to be willing to accept an approximate count. You cannot have a precise row count. So if you need precision, okay, well, precision means less speed. If you want speed, speed means less precision. You can get an approximate count. Let's see. And then table variable deferred compilation. This is very similar to what it's doing inside of the multi-statement table value user defined functions. It's actually, instead of compiling immediately with a guessed row count, it actually defers the compilation a little bit and tries to get a more accurate row count before it compiles to retrieve your plan, and therefore, makes it a little bit better. Again, like the multi-statement table value user-defined functions, it's not earth-shatteringly better. It's just an improvement. It's better. It is, but it's not radically better. Okay, no questions so far. Cool, we'll keep going. Now, this one I frankly am quite excited about. I love it to death. I think it's fantastic. Mainly because more and more and more of us are not managing a database or even a server. More and more of us are managing 10 servers, 100 servers, 1,000 servers, 5,000 servers. And when you're managing 1,000 servers. You're not going to sit around tuning queries except in the places where it's heinous, where it's horrific, where, oh my God, we have to fix this, otherwise the servers won't come back online. Cool, we're going to tune those queries, obviously. But all the little day-to-day little things, like where, oh gosh, if only we had an index here, or only we had a thing there, this does it. And this is Azure SQL Database only, by the way. But it is the coolest thing in the world, because what they've done is they're weaponizing Query Store. They're turning Query Store into this thing that can do more automatically. Now you get the choice as to whether or not you want to turn this on. But what it will do is it creates covering indexes. Cool. And it does it across all the databases that you have in Azure. Cool. And it does it automatically. Further, it can drop indexes. If it determines an index is not being used, it will drop it. Now, here's the real key point though. There's one kind of index this will never create, and that is a unique index. And there's one kind of index it will never drop, and that is a unique index. Unique indexes have all kinds of functionality inside them that the optimizer uses the heck out of. So you need to make sure that you're picking unique indexes on a regular basis, but also need to know that if you're in this situation, if you're doing Azure SQL Database and you're relying on this thing, which is using machine learning to make its decisions, which is so cool, it's not going to drop the unique indexes that you create. That's a huge, huge and important part of how this thing works. It will only ever drop non-clustered indexes. Cool. But the ones it's going to drop are the ones that are not being used over time, and this thing is very good. Now, I'm not going to demo this today. Demoing this, it takes, I've demoed it. I know how to demo it. I can make it work, but it takes, a couple of days of running the queries to make it actually kick off. It takes time. And I guess I could record one over 2 days and then speed it up into a 90-second, preview, but trust me, it works. It works well. Now, does it work as well as you? Does it replace the Mark I eyeball? Not at all. Not at all. You are going to be able to tune the queries better than this can. Guaranteed. I guarantee you can tune the queries better than this can for 2 reasons. One, this can only create an index. It's the only thing it can do. It can't modify the code. Also, it can't modify the structure. If you're missing a foreign key constraint, you could add that. This thing doesn't know that you're missing a foreign key constraint. If you need to restructure your tables to have a better approach to the way the data is managed, you can do that. This thing's not going to know that you need to do that. This doesn't understand your business, you do. This doesn't understand the behavior of your application, you do. This understands the behavior of SQL Server as it relates to indexing. And that's it. It can spot places where it could add an index to improve your performance. Cool. Great. I mean, that's great. It's a win, right? Take it and run with it. It's a win. It's not as good as you. It will not replace you. It's just not going to. But what it is when you've got 100, 1,000 of these things that you have to manage, having the automated thing do all the easy, low-hanging fruit stuff so you don't have to is a win. It just makes it better. And the fact is, if you don't like it, turn it off. It's nothing you have to take in, use automatically. You can just turn it off. So I love this thing to death. I really do. I've enabled it on every Azure database I've ever had to manage. It works. It does a good job. Again, not as good as I can do, and certainly not as good as you can do. And I'm assuming you all can do better than me. But this does nice work. It's not something to be scared of. Now, in 2017 and above, 2017 and 2019, and only in 2017, not in Azure, funny enough, there is this thing called automated plan regression. Now, I'm going to demo that here shortly. Automated plan regression is amazing. I love it to death. This is another one that just gets me so excited. It's an additional weaponization of Query Store. And I know what you mean when what do I mean by weaponization? I mean that they're taking the knowledge in Query Store and using it to change the behaviors of SQL Server. Because if you capture all kinds of really cool stuff about a query, such as, how long did it run on average? Well, what's the standard deviation? Have we gone like more than 3 or 4 or 5 steps beyond a normal standard deviation? Well, gosh, that's bad. Let's fix it. Can we go back to a good plan? Right? The plan changed. Well, let's look at a different plan. Can we do that? And hey, by the way, do we need to have someone come in, put the Mark 1 eyeball on it, and take care of that manually? Couldn't we spot that regression and apply it? Further, after we apply it, couldn't we measure it over time and say, like, yeah, in fact, that did help. Cool, let's leave it in place. Or, oh, wow, that was bad. Let's undo it. Yes, you could do all of that in an automated fashion. Again, this is the whole idea of the low-hanging fruit, the easy stuff, the stuff, sure, you could do it, guaranteed. But why not let the tool do it for you? It's going to be faster. It's going to be easier. And when you're dealing with 1,000 servers, win, right? It's just a win. It's just an easier way to get things done. Now, a few things about it. It is 2017 and up, right? And it's not on Azure. It's 2017 to 2019. It is not on Azure. Next, it's only the last good plan. It doesn't look at 2, 3, 5, 6, 8 plans and say, oh, which of these is the best and which one's called the most frequently. No. It doesn't do any of that kind of stuff. You want that? You know where you get that? That's right, you. You will be doing that. But if you want to see the last good plan, the last time an execution plan was better than the one you have now, this will take care of that, and it will apply it. And then if it likes it, it will keep it. If it doesn't like it, it will remove it, and you don't have to worry about it. Those will show up as forced execution plans. So if you're used to looking at Query Store and looking at forced plans, this will show up the same way, so you can see it inside there. I love this to death. I mean, it is just some of the greatest functionality going on. The Query Store in and of itself is amazing. When they introduced it in 2016, I fell in love. And plus, I'd known about it for like 8 years before it came out. They've been working on it for quite a while. In fact, if you look at 2014, the system views, there are Query Store system views inside SQL 2014. You can query them. It returns no data. There's no functionality there. But what it is that Query Store almost made it into the 2014 product, but then it got bumped and made it into 2016. But anyway, with the release of 2017, 2019, Microsoft has taken Query Store and run with it. And you are using all the great knowledge that it gives you to automate mechanisms. So that makes query tuning easier for you. Again, not easy, because the hard parts of query tuning, deciding where deciding where unique indexes should go, deciding the primary key, deciding the clustered index, that's all still on you. Making sure that you've got a good structure, foreign keys, and that the foreign keys are enforced, that's still on you. Making sure that you're normalizing your data structures, and normalization is a performance enhancer, not denormalization. That one makes me crazy. Normalization is a performance enhancer because you're reducing data storage and therefore I/O, and I/O is never our friend. So the more I/O we can reduce, the faster our performance goes. Anyway, this is fantastic. Now, if you're managing one database, are you going to turn this on? Yeah, maybe. It could be helpful. Not as much so, because you're going to be able to go in and look at your stuff yourself and no problem query tune it and fix it, and off you go. If you're managing, 100 servers with X number of databases, are you going to turn this on? Yeah. Yeah, let this take care of the easy stuff, and then you move on. All right, let's see. Now we're going to switch over to the demo. Any questions so far? No, cool. All right. Let's go. You should be able to see my screen. Now, this demo is from Microsoft. Microsoft's got this posted online. You guys can go and download it yourself. I'm not going to run this first part. All this is doing is creating a table. In fact, really, it should have 2 more 9s here, but I was running into some issues when I was setting up earlier, so I did a little cheating and ran it 10 times and got to where I needed it to be. So I'm not going to run this part of it. You can run that on your own. I am going to walk you through what this does and why, and then we will show you the results. Okay? So what I'm doing first is I'm clearing the procedure cache for my database, just because I want the query that compiles here to be the first time it compiles, so that we run it, the first time, and that's the way it runs. Now what I'm going to do is I'm just going to run it one time for you guys right now, and we're going to capture the execution plan. So we're going to run it, and this is the execution plan. So it's doing a column store index scan, huge number of rows, hash match aggregate, and off it goes. Okay, so you get the idea. And the actual result is it came back with one row. So cool. That's the normal execution. Now, if we were to change it up, clear the procedure cache again, and then execute it, but pass it in a different type. So instead of type 2, we're going to pass it in type 1. Now let's just execute this and capture the execution plan. So you see what we've got now is a very clear index seek, because it's on a, it knows that it's got good data. It's doing a stream aggregate. It's a completely different execution plan, utterly different. And the results in this case, again, one row. But the key point here is the count. Oh, sorry, I keep saying one row. The results here are 15 rows, and the results up here are, what was it? I forget. Silly Grant. Hang on one second. Yeah, the results up here are a lot more. What was that, 1.3 million? Cool. So what happens is that we're going to execute this one 30 times with that one type. So it's returning those 1.3 million rows 30 different times. Now the reason we're doing it 30 times is because it needs to establish a track record, a normal behavior, okay? Then we're going to recompile it so it gets that second execution plan, not the scan, but the seek. But then we're going to run 15 times with the different parameters, so it's returning again 1.3 million rows, but it's returning 1.3 million rows through a seek process. So if we run those two, it only takes about a minute or so to run these, or should. Let's see what happens. There it goes. It's running. So it's going to run 30 times to establish the normal behavior. Then it's going to change the behavior and run 15 more times to find that, hey, there's been a deviation. Okay, and now it's finished. Now, you're going, hey, what happened? Well, let's go and take a look. Now, here's the query that Microsoft supplies. And so what we're doing is we're going to sysdmdb tuning recommendations. Now, this is the fun thing. It doesn't automatically turn this on. You have to turn it on, but it automatically captures it. So any of you out there that are running 2017 right now, you can go and run a query against sysdmdb tuning recommendations, and you can see places where the optimizer is going, hey, you know what? You've had a plan regression. This query plan is now behaving poorly, and let me tell you things that you could do to fix it. So here's how it works. The details are in JSON. Yeah, I know, a lot of you already just went, and I'm done. Hey, steal my script. Well, I'm sorry, this is Microsoft script. I'll show you mine in a second. You can steal mine, and Microsoft definitely wants you to steal theirs, so please use it. So what we're doing here is that it's doing the JSON query to pull back the query ID, the plan ID, the regress plan error count, the recommended plan error count, and a whole bunch of other stuff. So this is the way Microsoft's got it all set up. And it's selecting those JSON values, and it's doing an estimated gain by doing this calculation up here, the regressed execution plan plus the recommended plan execution plan times the CPU average minus the estimated plan CPU average divided by 10 million, just to give a number that means something, right? Cool. We will execute this, and the results come back. And so what we've got is a nice descriptive reason. Average query CPU time changed from 0.06 milliseconds to 85 milliseconds. That is the scan of the index ran in 0.06. The seek against that same index ran in 85 milliseconds. So from a point from, what is that, 60 microseconds to 85 milliseconds. That is a massive, massive hit on performance. Massive. So it gave it a fairly high score, and it gave you the script. Hey, you know what? This is what you ought to do. Run SP query store force plan. It gives you the query ID and the plan ID. And you can see the query ID, you can see the plan ID, you can see the recommended plan ID, you can see the average CPU count, the number of executions, and the execution gain. So you can get all that stuff, and are there errors in there? Cool, it's all great info. Well, we can even get more info out of it, because all we have to do is just join it to other information. So this is a query I wrote. Doing the same idea, going to sysdm DB tuning recommendations. Okay. Cross apply to the OpenJSON to pull the stuff back, and doing all of this within a little, what do you call it? CT, common table expression. The common table expression is pulling back some values, and then I'm going down here and saying, okay, well, cool. I've got, the plan ID and the query ID. So let me go into query store and get the query ID. Where for the query plan ID, let me go into query store and get the recommended plan, so I can get both plans. Let me pull all that stuff back out, casting the plans as XML, and pull all that together. And the reason that I'm doing it this way is for one reason and one reason only. If I want to look at the estimated plans, cool, it gives me the same information that Microsoft did, right? Because I'm not doing anything special. I'm just going to the same place they are. But I've added in these two plans so I can say, hey, you know what? Let me take a look at the plans and let me see. This is the plan that was causing us problems, and this is the plan that worked well. Or did I get those backwards? No, I got them right. No, I got them backwards. No, I got them right. I got them right. This is the plan that worked well. This is the plan that gave me problems. But we can go in there and look up both plans and see what's going on and make the determination which plan we ought to be using. That's cool. So we don't have to rely on this thing as an automated tool, although, frankly, I would. But if you just want to take advantage of it, you can, which is cool. Now, if you want to turn on automated plan forcing, it's hard. Run this, off you go. It's just gonna start working. Now, if you want to, you can run queries against it to see what's going on. Are you in automated forcing or not? I am in auto, actually. It will start forcing those plans. And then you can turn it off. Doesn't require reboot or anything else. You just turn it on, turn it off. I'm going to turn it off because I thought it actually was off. I want to have it off because I don't want it to automatically do stuff for me. Okay, that's it. All right, let's take a look at interleaved execution next for our next demo. Any questions on that one? You guys saw how that worked? Cool. All right, interleaved execution. What I'm going to do is I'm going to create a multi-statement table-valued user-defined function. And so it inserts stuff based on a select statement. Cool. I'm then going to create another multi-statement table-valued user-defined function. And then I'm going to create another multi-statement table-valued user-defined function. And it's going to join the other two multi-statement table-valued user-defined functions. And before any of you go, oh, no one would ever do this. Yeah, in fact, I had to work on code where people had done this 86 layers deep. 86 layers of multi-statement table-valued user-defined functions joining multi-statement table-valued user-defined functions, which did all kinds of joins against multi-statement table-valued user-defined functions and blah, 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 blah. Okay, hang on. We're going past where the multi-statement table-valued user-defined functions are. There we go. Cool. Awesome. Just want to make sure they're created. They are. Awesome. Now, let's turn off the interleaved execution, and we can do that database by database. We're going to turn it off. I want to see the old behavior. Cool. Oops. That should be right. What? What is going on? Hang on. Am I in the wrong? Hang on one second. Maybe I've got the wrong... No, I'm on 119. Or I'm sorry, 150. Huh. Well, that should be working. All right, well, let's see what happens when we run this. And we're going to capture the execution plan. Cool. Yeah, okay, it's working. Cool. But I can't turn it off. All right, that's odd. I'm going to have to look at my syntax. Apologies for messing up the syntax. I will fix that another day. But we can see that it's working because we can see the estimate is 19. So why 19? Well, because as it's executing, it's figuring out which of these things it needs to be running. Now, this actual plan is interesting because it's hiding a lot of the functionality. If we take a look at the estimated plan, the estimated plan shows us everything that's really going on behind the scenes. And what's really going on behind the scenes is we have this nested loops join against these things, and we've got this hash join against these things, and we've got this other hash join down here, and then this other table insert down here. And it's all of these things that are the normal execution of that one set of multi-statement table valid user-defined functions. It's all of this functionality. And so you can see that there's a lot going on here, including the suggestion, hey, maybe if you had an index, it would be faster. So it's all cool stuff. But we've now got the ability to turn that on and off. It's on by default in 2019. But you can turn it off. Although, I'm not. What the heck? That's frustrating. Well, apologies. I apologize. That should work. All right, well, let's take a look at the memory grant. We're going to clear the procedure cache, just so we're going from scratch. We're going to make sure that we've got a non-clustered column index on this table. I believe I already do, so this is just going to cause an error. Oh, no. Okay, it's cool. It's creating it. Let's give it a minute there to create that, make sure it's in place. Before we keep going, does anyone have any questions? Nope. Okay, cool. I'm keeping an eye on the live chat over here. All right, let's go. Hurry up. Today. Give us a sec. By the way, this is against the big transaction history table. Adam Mechanic wrote a set of scripts quite a while back called Big Adventure. And it's basically a way to create a couple of very large tables inside of AdventureWorks. So I would look that up, Big Adventure, Adam Mechanic. And what I'm doing is I'm using that really large table to create a non-clustered column store index against it. It should be done by now. Come on. You're making me look bad here. Hurry up. Just in case. Nope, no questions. Hang on one second. This will clear in a second. It's just taking longer than it ought to. Usually only takes about 2 minutes. Oh, we're not at 2 minutes yet. We're only at 1:30. Okay. I'm being impatient. Sorry about that. Trust me, this one's fun. And we're also going to look at the adaptive query join, or adaptive join here as soon as this finishes. Excellent, thank you. Look at that, 154. I knew it only took about 2 minutes. I'm a bad person. All right, here we go. Now, if we execute this, this is going to recreate the store procedure. Excellent. If we now execute the store procedure, and we're going to capture the execution plan. I'm going to take a moment first and talk about the adaptive join. and then we'll take a look at the memory configuration, okay? So the results come back. This returns a row. Cool, not hardly a shock. It did go parallel, so we have parallel execution, and we see right here the adaptive join. Now the adaptive join is showing us that it's got two paths. Remember, when we talked about the adaptive join, it can do a hash join or it can do a loops join. In this case, what it did was a loops join. Now, ask me how I know. The reason I know is because of the actual values, because we did do an execution plan plus runtime metrics, and so it's got one row of 50. And then this one says 0 rows. And it's always the same. The top is the hash path, and the bottom is the loops path. It's always the same way every time. Now, let's take a look at the properties on this adaptive join. Sorry, I'm tilting my head in case you're watching the corner of the screen because my microphone is in the way. Oh, nuts. I already had the properties pinned, didn't I? There we go. Let's just make them a little bit bigger. There we go. All right. Let's zoom in. So, there is our adaptive row threshold, 148.961. So what happens, again, the way we described it, it's going to make a determination if it's doing a loops or a hash based on that row count. In our case, it returned 1. 1 is less than 148, and therefore, ta-da, we got a loops join. Yay. And so you can see that the adaptive threshold, and so you can actually make the determinations yourself to see whether or not in which direction it's going to go every time. So it's not like a surprise. The information is there. And so there's nothing else going on. Also, it's going to tell you what operation it did. In this case, it says, hey, I did an inner join. It also tells you that it is adaptive, and off it goes. And so all of that fun stuff is all right there, all built in, and that's the adaptive join process. Now, let's also look at the memory grant information. Now, we've already flushed the cache, so this is the first time this thing is run, so there's nothing for it to compare to. And if we take a look at the memory grant info, which is stored with every execution plan, you get two sets of info. You get the execution plan, and then you get the execution plan plus runtime metrics. So the desired memory and the granted memory. And so you can see that the granted memory in this case is 104.5.864, even though the desired was 330.0248. Okay, cool. Is memory grant feedback adjusted? No, this is the first execution. Cool. Let's go execute it again. Same query. Now I'm going to turn off the execution. Well, yeah, I'm going to turn off the execution plan for the moment. Same query. Oh no, I need the execution plan. Silly grant. It's okay if we execute it 3 times. Now, again, we need to go to the first operator in the properties, and we need to take a look at the memory grant info. And in this case, we then see the desired memory has changed because the plan has been recompiled to a more accurate memory. And so now the desired memory is 11.304, and the granted memory is 11.304. So it's actually adjusted itself down over those executions that we saw, and it says yes, it is in fact adjusting the information because this is a new execution. Now what happens if we change the behavior of the query? What happens if we modify the parameters? Let's take a look at that. Yes, it's taking longer to run. And it's a different execution plan than what we had before. But let's take a look at the memory grant info. Now it's saying, is it adjusted? No, it's stable. It's stable, but it's a different set of data. Take a look at the results. Yeah, it's 9,000 rows. That can't be right. So let's execute it again. And again, it's painful. So let's check. Now, it could be that we've made it stabilized by running it a couple of times. I can usually make it a bounce. Ah, nope, there it goes. So you'll notice we have again adjusted the memory. It took me a couple executions to make it bounce, but it adjusted the memory a second time because as it executes multiple times, it's going, hey, wait a minute, this memory allocation is not right. I need to make some adjustments, and so it's making the adjustments to the memory on the fly. So this is going to make it so it's better at managing your information, better at managing your memory than it was previously. This is just cool stuff. And this is all automatic. This has nothing to do with anything, the queries or anything else. This is just built in and running. It's part of SQL Server 2017, part of SQL Server 2019. All right. And that is the last demo I have today. Let's go back to our slides. So if anyone has any questions, now's a great time. I'll give you a couple of seconds to type in those questions if you have them. Additional reading, SQL Server 2017 Query Tuning book doesn't cover some of the 2019 stuff. There's a few things added in 2019 that I didn't get to, didn't cover, but almost everything else is there. So everything we've covered all 8 weeks of this course is largely covered within that book. The SQL Server Query Store, the Query Store for SQL Server 2019 book, it's Tracy Baggiano's book, but I helped a little bit, and that covers Query Store in great detail, including the automatic stuff that we showed earlier. And then the SQL Server Execution Plans book, 3rd edition, it covers everything. That's a major rewrite. There's a free copy to download for you, or if you want the paper version, you have to pay for that. These are all on the slides, which are on slideshare.net. You can download those right now. And that, my friends, is it. That wraps up the 8 classes that we had planned for this series on the built-in tools that make query tuning easier. I hope all of it was very helpful. If you have more questions, I will continue monitoring YouTube to see if you have questions there. Or there is a Discord server that I set up for this class as an experiment. So far, nobody's using it much, but it is there for if you have questions after today, you can track it down. Otherwise, at the beginning of class, you saw my email. You can use that. If you have questions after today, I want to try to help out. Otherwise, that's it. We're going to wrap it all up. That's our 8 classes all done. Hopefully, this was helpful. You got something out of it. And other than that, have a good day. I hope you guys enjoy it. And that's it. My name is Grant Fritchie. I work for Redgate Software.